In 2025, Arizona is no longer just the land of cacti sunsets and wide-open desert highways. It has transformed into a sprawling construction zone, with cranes, bulldozers, and engineers leaving their mark on nearly every corner of the state. What was once a quiet desert backdrop is now the stage for some of the most ambitious infrastructure projects in the nation. From futuristic rail lines threading through Phoenix's urban core to highways so vast they look like something out of a sci-fi movie, and from industrial megaparks to renewable energy farms stretching across the high desert plains, Arizona is reinventing itself. The scale is staggering, the ambition is bold, and the impact will echo for generations. Let's dive into the projects that are making Arizona not only a hub of innovation, but also one of the fastest-growing construction powerhouses in America. Building transit equity. Valley Metro's South Central Extension. Phoenix has been one of the fastest-growing cities in the U.S. for years, but its transit network has struggled to keep up. Enter the Valley Metro's South Central Extension, a 5-mile stretch of rail that connects downtown Phoenix to communities along South Central Avenue. On paper, it may sound straightforward. Lay down tracks, build stations, connect neighborhoods. In reality, it's an urban engineering ballet. Every inch of track had to be carefully coordinated with a web of existing utilities, gas lines, water mains, fiber optics, and electrical conduits that form the veins of the city. Instead of blindly digging, crews turned to ground-penetrating radar and vacuum excavation to map what lay beneath. Only then could they start relocating pipes and cables, a process that had to be phased in to avoid knocking out essential services for businesses and homes. The desert environment brought its own set of challenges. Phoenix may be bone dry most of the year, but when it rains, it pours. Flash floods are no joke, and stormwater had to be accounted for. Civil engineers built underground detention systems, complete with retention basins, to prevent intersections from turning into rivers every monsoon season. Perhaps the most striking aspect, the rail itself. Continuous welded rails were delivered in massive lengths, welded on-site using molten steel, and laid with surgical precision. Overhead power systems were strung across the desert sky, their copper wires tensioned with devices designed to adapt to the punishing Arizona heat. Stations became more than just waiting areas. They were designed as community landmarks, featuring desert-friendly landscaping, drought-resistant plants, and even public art collaborations with local creatives. It wasn't just about transit, it was about identity. The extension, once complete, will do more than shorten commutes. It represents equity, giving historically underserved communities direct access to the economic heart of Phoenix. In a city built for cars, that's a monumental shift. The Broadway Curve. If you've ever driven through Phoenix, you know the Broadway Curve on Interstate 10 can test the patience of even the calmest driver. This 11-mile stretch carries more than 300,000 vehicles a day, commuters, freight haulers, and the occasional snowbird pulling an RV. For decades, it has been the region's biggest bottleneck. Arizona's answer? Blow it wide open. The Broadway Curve Improvement Project is a freeway expansion unlike anything the state has attempted. Engineers began by drilling boreholes, sampling soils, and testing groundwater levels. Why? Because before you can build bigger, you need to know what you're building on. The data informed how deep foundations should be, how tall retaining walls could go, and how to keep the highway from cracking under Arizona's infamous heat. Once demolition started, it was a sight to behold. Crews knocked down old bridges, tore up lanes, and removed sound walls, all while controlling dust with mist cannons and water trucks. Nothing went to waste. Concrete was crushed and recycled, asphalt reused as base material for temporary roads. The new design adds general-purpose lanes, HOV lanes, and auxiliary ramps. Bridges like the one at Broadway Road were completely reimagined. Precast girders weighing thousands of pounds were hoisted into place under the cover of night, minimizing disruption. Road surfaces themselves got an upgrade. Portland cement concrete for the heavy truck lanes, and polymer-modified asphalt for ramps that flex under extreme temperatures. Beneath the pavement, a web of drainage pipes, catch basins, and basins ensures runoff won't overwhelm the desert landscape, but the real magic lies in the technology. Dynamic message signs, traffic sensors, and cameras feed into ADOT's operations center, turning the Broadway Curve into a smart highway. Picture this: you're driving at rush hour, and the signs above you change to open or close lanes based on real-time traffic. That's the future, and it's happening in Phoenix. The Broadway Curve is not just about smoother commutes. It's about fueling Arizona's economic engine, making sure goods, workers, and families move efficiently through one of the busiest corridors in the Southwest. Skyscrapers over a bus terminal. Now, let's zoom downtown. While Phoenix is known for sprawl, the Central Station East and West Towers are bringing vertical ambition to the city's skyline. Imagine this: you're building two mixed-use high-rises, not on a vacant lot, but directly above the city's busiest bus and light rail hub. Shutting down transit wasn't an option, the solution. Engineers created a massive temporary decking system supported by steel beams, allowing construction crews to work above, while buses continued rolling below. The towers themselves were feats of structural engineering. Deep mat foundations and drilled shafts, some stretching more than 100 feet underground, carried the immense weight. Self-climbing formwork created the central concrete cores, while floor slabs were poured on a weekly cycle. Inside, the complexity was mind-bending. Building information modeling coordinated every pipe, wire, and duct before they were installed. Mechanical floors were spaced throughout the towers to house the lungs and veins of the building: vac units, water pumps, and electrical gear. The facades combined shimmering glass with shading devices designed for Arizona's brutal sun. Beyond aesthetics, they cut down on energy use and muted the noise of downtown traffic. When complete, these towers will fuse residential, retail, and public space into a transit-oriented community where people can live, shop, and hop on a bus or train without ever stepping into a car. Number 5. Mac Innovation Park. Out on the expanding edges of the Phoenix Metro, the Mac Innovation Park is rising as a mega industrial hub designed for logistics and advanced manufacturing. Picture acres upon acres of warehouses and research facilities, all master planned to plug directly into Arizona's booming economy. The site preparation alone was massive. Crews stabilized sandy soils with cement treatments, while lime was used in clay-heavy areas to prevent swelling. Underground, a maze of utilities was laid, from stormwater systems to dual-feed substations capable of delivering reliable power to energy-hungry tenants like data centers or chip manufacturers. The warehouses themselves were built using tilt-up concrete panels, a fast and cost-effective method where walls are cast on-site, lifted with cranes, and welded into place. Long-span steel joists created cavernous spaces inside, perfect for both forklifts and advanced robotics. Flexibility was key. Wide column spacing, high ceilings, and heavy-duty floor slabs allowed buildings to adapt to everything from e-commerce distribution to high-tech research. Truck courts, loading bays, and parking lots ensured smooth logistics flow. Even the landscaping reflected sustainability, with desert-native plants and efficient drip irrigation. LED lighting with motion sensors kept energy costs low while ensuring security. The Mac Innovation Park isn't just about buildings. It's about Arizona staking its claim as a manufacturing and logistics hub of the Southwest. Buc-ee's in Goodyear. If highways are Arizona's veins, then Buc-ee's is the heart that keeps travelers fueled. Famous in Texas for being part gas station, part shopping mall, part cult phenomenon, Buc-ee's made its grand debut in Goodyear, Arizona, and it's every bit as colossal as its Lone Star siblings. Forget the image of a dusty roadside station. Buc-ee's is supersized Americana. Picture 100-plus fueling stations, a building larger than an airport hangar, and aisles of food, snacks, and Buc-ee's branded souvenirs. There's fresh brisket being sliced in the kitchen, a bakery turning out kolaches, and walls of jerky that stretch further than your local grocery store. It's not just a gas stop, it's a road trip destination. But getting this giant built was a feat of civil and structural engineering. The desert terrain posed challenges, with uneven grading and natural drainage channels running through the site. Bulldozers and GPS-guided graders reshaped the land into perfectly level pads to support the massive retail building, the sprawling fueling canopy, and the acres of parking. Utilities were next. Few facilities consume resources like Buc-ee's, So the project demanded new electrical transformers, water supply upgrades, reinforced sewer lines, and a dedicated fire suppression system. The electrical backbone had to support enormous HVAC systems, commercial kitchens, car wash facilities, and non-stop lighting. Engineers essentially wired the site like a small town. Under the canopy, the lifeblood of Buc-ee's, fuel, was handled with extraordinary care. 30,000-gallon underground storage tanks were buried in concrete vaults, fitted with vapor recovery systems and leak detection technology. To prevent tanks from floating upward during groundwater surges, anchoring systems were installed. Fuel moved to pumps through double-walled piping encased in protective sleeves, ensuring maximum safety. Traffic management became the next frontier. Buc-ee's isn't just a stop. It's a magnet for hundreds, sometimes thousands of vehicles per day. Engineers redesigned the surrounding roads, carving out new turn lanes, deceleration lanes, and even building new traffic signals to manage the tidal wave of cars, RVs, and delivery trucks expected daily. The structure itself used a steel skeleton with reinforced masonry walls, designed to withstand both extreme heat and heavy foot traffic. High-performance insulation and glazing reduced cooling loads, while durable interior finishes like epoxy floors and stainless steel fixtures were chosen for longevity. For Arizona, Buc-ee's is more than a pit stop. It's a cultural statement. It represents the collision of consumer culture and mega-scale engineering, where infrastructure and retail meet in a desert-sized package. It's proof that even gas stations can be landmarks. State Route 505. Arizona's population boom is rewriting the state's map. Suburbs that once seemed hours from Phoenix are now bustling communities, and with growth comes the need for new arteries. Enter State Route 505, a highway project designed not just for today's traffic, but for decades of expansion. The project began, as all good highways do, from the ground up. Engineers performed extensive geotechnical testing across the proposed alignment, sinking boreholes and analyzing soils. In some sections, they encountered clay-rich floodplains notorious for swelling during seasonal rains. Left untreated, these soils could buckle pavement. The solution? Lime stabilization and geotextile reinforcements, a combination that transforms unstable soil into a solid foundation capable of bearing heavy loads. Crews also embedded settlement monitoring devices along key stretches. These instruments track ground movement over time, ensuring that the road remains stable as embankments compact and heavy trucks pound the surface. The pavement design itself was equally forward-thinking. Instead of a single layer of asphalt, the 505 boasts a multi-layered system, crushed aggregate base, topped with polymer-modified asphalt that resists rutting, cracking, and heat damage. This makes the road tougher and longer lasting, crucial in Arizona's punishing climate. The interchanges were engineered with an eye toward efficiency and land conservation. Single-point urban interchange is a modern design where all traffic passes through a single set of signals, allow more vehicles to move in less space. These futuristic-looking intersections reduce congestion without gobbling up large tracts of land, which is critical in developing suburban corridors. But perhaps the most impressive aspect of Route 505 is its technology integration. Intelligent transportation systems were woven into the project from the start. Sensors monitor traffic volume, cameras provide real-time feeds, and overhead dynamic message boards update drivers instantly about accidents or delays. LED lighting was installed for visibility and energy efficiency, while the drainage network was modeled for 100-year storm events, complete with reinforced culverts and detention basins to protect surrounding communities. State Route 505 is more than a strip of asphalt. It's a blueprint for modern highway design. Built tough, built smart, and built scalable, it reflects Arizona's commitment to staying ahead of its rapid population growth. West Camp Wind Farm. Northern Arizona's wide-open high desert plains might look empty at first glance, but in 2025 they became the foundation for one of the state's boldest pushes into renewable energy, the West Camp Wind Farm. The project wasn't built overnight. Long before a single blade was lifted skyward, engineers spent years studying the weather. Meteorological towers rose across the plains, capturing data on wind speed, direction, turbulence, and seasonal patterns. Every reading helped fine-tune turbine placement, ensuring maximum efficiency and minimal environmental disruption. When it came time to build, the foundations were a marvel in themselves. Each turbine required a circular concrete pad more than 60 feet across and over 10 feet deep, reinforced with steel cages. In some locations, crews had to anchor foundations directly into bedrock to withstand decades of constant loading from desert winds. Transporting the parts was a logistical feat. Tower sections longer than city buses, nacelles the size of small houses, and blades reaching 150 feet each rolled into Arizona on convoys of specialized trucks. In many cases, rural intersections had to be temporarily regraded or widened to allow passage. Local residents became used to seeing surreal, spaceship-like equipment inching down highways. Assembly required cranes of extraordinary capacity, crawler cranes with booms stretching hundreds of feet into the air. One by one, tower sections were stacked, nacelles installed, and blades lifted in precision maneuvers timed carefully with weather windows. A sudden gust of wind at the wrong moment could delay installation for days. Beneath the ground, a hidden network of medium-voltage cables connected the turbines to transformers, then to a central substation. From there, high-voltage transmission lines carried the power into Arizona's grid, supplying clean electricity to homes and industries. But sustainability didn't stop with power. Environmental teams monitored every phase. Dust suppression systems kept the desert air clean. Wildlife biologists tracked habitats of raptors and desert mammals. Once construction ended, disturbed soil was regraded and reseeded with native plants, ensuring the land returned to its natural state. The West Camp Wind Farm now stands as a futuristic forest of steel and fiberglass against the Arizona sky. More than just turbines, it symbolizes Arizona's commitment to renewable energy and proves that even the desert, long associated with heat and sun, can harness the wind to power the future. Mattel Adventure Park. Not every mega project in Arizona is about highways or power grids. Some are about fun on a massive scale. Welcome to Mattel Adventure Park in Glendale, a place where engineering meets imagination and toys literally come to life. Unlike a traditional theme park, Mattel's project combines retail, storytelling, and thrill rides into one hybrid destination. For families, it's a dream come true. For engineers, it's one of the most complex builds Arizona has ever seen. Take the roller coasters, for example. Each one required deep pile foundations drilled dozens of feet into the desert soil to support the crushing dynamic forces of looping track and screaming riders. Engineers ran structural analysis simulations, testing how the steel frames would handle not only ride forces, but also seismic activity, because in Arizona, earthquakes, while rare, still need to be factored in. Indoor attractions were just as demanding. Giant pre-engineered steel buildings rose from the desert floor, their facades dressed in themed cladding that could resemble anything from Barbie's dream house to Hot Wheels garages. These facades weren't just for show. They were weatherproof, insulated, and treated with coatings to withstand decades of desert sun without fading. Climate control was another mountain to climb. When the thermometer reads 115 degrees Fahrenheit outside, you can't risk overheated guests or malfunctioning rides inside. Massive rooftop air handlers and chilled water loops keep the interiors cool, with backup systems in place to guarantee comfort, even during power surges or outages. Power demand, in fact, rivals that of small cities. Lighting rigs, sound systems, ride motors, kitchens, and retail shops all connect to a central utility corridor designed to distribute electricity seamlessly across the park. Fiber optic networks were embedded too, ensuring high-speed connectivity for ticketing, security, and even interactive attractions. Even the queue lines got special treatment. Instead of endless zigzags under the sun, guests wait in shaded, themed environments filled with digital screens, interactive displays, and storytelling elements that make the line part of the ride. Structural engineers, landscape architects, and scenic fabricators work hand in hand to make waiting entertaining. At its core, Mattel Adventure Park isn't just an amusement park. It's a bold experiment in blending industrial ride engineering with immersive retail. It proves that Arizona's construction boom isn't just about moving cars and powering homes. It's also about creating joy at scale, turning childhood dreams into steel and concrete reality. And that wraps up our deep dive into the massive construction projects transforming Arizona in 2025. If you enjoyed this video and learned something new, make sure to hit that like and don't forget to subscribe. Thanks for watching. Until next time, keep looking up at the skylines, because the future is being built right now.